This is the sound of sperm whales. With a brain that can weigh up to 18 pounds and a lifespan of more than 200 years, they're considered to be among the most intelligent animals on Earth. They communicate using clicks called codas, and now scientists say we are closer than ever to actually understanding them, where researchers at Project SETI are using artificial intelligence to decode the clicks.
It's possible that they're communicating in ways that we've never thought of before.
The hope is that one day, for the first time, we'll be able to have full conversations. What do humans have to gain from a conversation with a sperm whale?
It has the capacity to bring us closer to the natural world in a way that the microscope allowed us to see inside a cell, or a telescope allowed us to see the stars.
It's like a whole new frontier.
It is a whole new frontier.
Beneath the surface of the ocean, an ancient language has been hiding in plain sight. Whales, giants of the deep, have been speaking to each other for centuries, their complex communications unheard by human ears. But now, with the help of cutting-edge AI, we're listening in. And what we've discovered is nothing short of revolutionary. The complexity of their language is shattering everything we thought we knew about intelligence and communication. For the first time, we may be on the brink of talking to them. The ocean's most guarded secret is about to be revealed. Are we ready?
What does one whale say that causes another whale to dive?
In terms of the first step of that then, like trying to uncover existing patterns in the data that you're collecting, like, do you see that there's a particular noise that whales make when another whale dives?
Yeah.
Wow.
These are a couple beluga communicating while hunting.
Go on. Sounds like radio static.
Right? Or an alien modem.
Yeah. An alien modem. I like that a lot. Yeah, I mean, I could listen to that for 100 years and never make sense of it.
Correct.
Yeah.
And mind you, scientists haven't been able to make sense of it, but we're at the cusp of having the tools to learn how to disambiguate, to solve what's called the cocktail party problem.
For centuries, the ocean's depths have held their secrets from us. Sailors returning from long voyages spoke of strange creatures lurking in the dark waters, many of which were thought to be myth. Some of these tales focused on sea serpents, while others described the eerie, melodic calls of whales. For many years, these sounds were simply part of the ocean's wonder, beautiful but barely understood. Though whales had always captivated our imaginations due to their sheer size, we never really thought they possessed intelligence that could rival our own. To us, they were just animals we could exploit, hunted for their blubber, bones, and oil.
A breakthrough for scientists after they had a 20-minute conversation with a humpback whale.
This is a little how their conversation went.
However, a single unexpected event changed this perception. In the 1970s, the world began to experience a new wave of environmental awareness. It was during this time that scientists already interested in marine life decided to focus on the humpback whales. They set out on research expeditions to record the sounds of these majestic animals. And what they discovered was nothing short of astonishing. The sounds these whales made were not random, as they had once been assumed. Instead, they were intricate and evolved over time, lasting for hours. The significance of this discovery was profound. These whale songs were not just simple sounds. They were complex vocalizations that conveyed meaning, much like the way humans use language to communicate. The recordings were eventually compiled into an album titled Asterisk Songs of the Humpback Whale Asterisk, which would play a pivotal role in changing public perception of these creatures. The album, in its own way, helped spark a global movement that brought the humpback whale back from the brink of extinction. But this discovery also raised more questions than it answered. Scientists, diving deeper into the emerging field of bioacoustics, the study of animal sounds, found themselves at a crossroads. Despite the advancements in their recording techniques, early researchers struggled to understand the true nature of whale communication. Was it simply a mating call? Was it a signal for help, or a form of social communication? No one knew for sure. For decades, we were limited in our understanding, held back by the sheer volume of data and the limitations of our senses. We could hear the sounds, but we couldn't interpret them. That was until a scientist named Dr. David Gruber stepped onto the scene with a bold idea that would change everything. Dr. Gruber, an American marine biologist and a researcher for National Geographic, realized that to truly understand whale communication, we would need more than the basic tools that had been used in the past. Instead, he looked to a completely different field for inspiration, one that was not just scientific but also technological: the search for extraterrestrial intelligence, or SETI. This was the field dedicated to listening for signals from outer space, in the hope of detecting messages from alien civilizations. Gruber's idea was revolutionary. What if, instead of searching for alien intelligence in the far reaches of space, we were missing the signs of alien intelligence right here on Earth? What if the intelligence we were looking for was already living beneath the waves, in the form of humpback whales? This concept, as outlandish as it seemed, laid the groundwork for a groundbreaking initiative that would become known as Project CET, short for the Cetacean Translation Initiative. But turning this theory into a reality would not be easy. Dr. Gruber knew that to truly unlock the secrets of whale communication, he would need more than just a few researchers. He needed a team. And not just any team, but a team made up of people from various disciplines. This was not going to be a simple study of animal sounds. The goal was far more ambitious: to establish a two-way communication system with another species. The team Dr. Gruber assembled would combine the expertise of marine biologists, computer scientists, linguists, and roboticists, all united by one shared vision. The challenge ahead was immense. The team wasn't just interested in documenting whale sounds. They were aiming to create a way to understand and communicate with these creatures. To do this, they would need to listen to the voices of the whales and understand who was speaking, to whom and why. It wasn't enough to simply record the sounds. They needed context, and for that they would need more than just the traditional recording methods. This approach marked a stark departure from traditional whale research, which had been limited by technology. The tools available in the past, such as basic recording devices, simply weren't enough to decode the vast ocean of sounds that these animals were producing. But with the help of modern advancements in technology, Dr. Gruber and his team were ready to tackle the task. And that is where the next phase of their research would begin, using AI to translate the language of the whales. The ocean is vast, and the creatures that inhabit it are even vaster. For years, humans have only scratched the surface of understanding the lives of these creatures. With the help of cutting-edge technology, we are now closer than ever to unlocking one of the greatest mysteries of the ocean: the discovery of whale language and the possibility of engaging in communication with them. Marks a monumental step forward in our understanding of life on Earth. For the first time, we are not just observing these animals from a distance. We are entering their world, hearing their voices, and starting to understand what they're saying. In the 1970s, as the world began to awaken to environmental issues, a remarkable discovery was made that would change how we understand marine life forever. Scientists, driven by growing concern for the oceans and their inhabitants, decided to focus on humpback whales. These majestic creatures had been the subject of fascination for centuries, but very little was understood about their behavior and communication. They were known to produce hauntingly beautiful songs, but the purpose of these vocalizations remained a mystery. It all began with an idea to record the sounds of humpback whales. Researchers set out to capture their vocalizations in the hope of learning more about these enigmatic creatures. What they discovered was far beyond their expectations. The sounds they recorded were not random. Instead, they were complex, evolving vocalizations that lasted for several hours, and they followed a particular pattern. The vocalizations were not just the result of a mating call or a random noise. They were intricate and structured, suggesting a deeper level of communication. These findings were groundbreaking, as they indicated that humpback whales, and likely other marine mammals, possessed a form of communication that was far more sophisticated than previously thought. In 1970, the recordings were compiled into an album titled Songs of the Humpback Whale, which quickly gained attention. The public was captivated by the beauty of the whale songs, and the album became a symbol for the growing movement to protect these creatures from the brink of extinction. While the release of the album was a turning point for public awareness, it also sparked a new wave of research. Scientists began to question how these vocalizations worked and what purpose they served. Were they simply mating calls? Were they used to communicate during social interactions? Or was there a deeper meaning behind them that had yet to be uncovered? As the years passed, the field of bioacoustics, which studies the sounds of animals, became increasingly important in the quest to understand whale communication. However, with the limited technology available at the time, researchers were still unable to fully interpret the complex sounds they were hearing. For decades, the mystery of whale communication remained unsolved. Early researchers used basic recording equipment to capture the sounds, often spending hours listening and analyzing the recordings. Despite their best efforts, they struggled to piece together the puzzle. The sheer volume of data made it difficult to discern patterns, and the tools available at the time were not advanced enough to decode the messages within the sounds. Scientists were left to speculate, proposing theories about the purpose of the sounds. Some believed that the whale songs were simply a way to attract mates, while others thought they were a form of communication used in times of danger or distress. But even as the questions piled up, the limitations of technology held back progress. While we could hear the sounds, understanding them was another matter entirely. This is where Dr. David Gruber, a marine biologist from the United States, came into the picture. Dr. Gruber's vision would change the course of research into whale communication. He believed that to truly understand these vocalizations, researchers needed to step beyond traditional methods and embrace new, more advanced technology. Dr. Gruber's inspiration came from an unlikely source: the field of extraterrestrial research. As a researcher working with National Geographic, Gruber had been following the work of the Search for Extraterrestrial Intelligence, SETI, a field that sought to detect signals from alien civilizations. The premise of SETI was to listen for unusual signals from outer space, hoping to detect evidence of intelligent life beyond Earth. Gruber saw a connection between SETI and the whale research. Both were trying to decode an unfamiliar language, one that wasn't human. He asked himself, what if the intelligence we were looking for was right here on Earth, in the form of the humpback whale? This idea seemed far-fetched to many, but to Dr. Gruber, it made perfect sense. What if we had been searching for alien life in the wrong places? What if the real mystery was already within our reach, in the depths of the ocean? Gruber's thoughts eventually led to the formation of Project SETI, the Cetacean Translation Initiative. The project's goal was to do something that had never been attempted before: establish a two-way communication system with whales. To achieve this ambitious goal, Dr. Gruber assembled a team of experts from various fields, each bringing a unique perspective to the project. The team included marine biologists, computer scientists, linguists, and roboticists. This multidisciplinary approach was essential because understanding whale communication was not something that could be solved by any one field alone. The team's vision was clear. They weren't just interested in documenting whale sounds. They wanted to understand them and ultimately to speak with the whales. The complexity of the task meant that no single discipline could address the challenge alone. Instead, the team would combine their expertise to break new ground in marine biology and AI. One of the first breakthroughs for the team came when they realized they would need more than just traditional recording tools. The idea of capturing whale vocalizations was not new, but to truly understand them, they would need to go beyond the simple process of recording. Dr. Gruber and his team knew they needed technology that could not only record the sounds but also help them decode and analyze the data on a much larger scale. The team also realized that to understand whale communication, they needed to know more than just what the whales were saying. They needed to know who was speaking, to whom, and in what context. This would require an entirely new approach. The challenge was monumental, but the team's determination was unwavering. With the help of advanced AI technology, they believed they could unlock the mysteries of whale language. AI could analyze vast amounts of data and identify patterns that the human ear could not detect. This was crucial because whale communication was far more complex than previously thought. The whales didn't just produce random sounds, each click, whistle, or moan had meaning. The team believed that by using AI they could interpret these sounds in a way that had never been possible before. The breakthrough that allowed Project SETI to move forward came in the form of an underwater recording studio. In 2019, the team began building the world's first underwater studio, specifically designed to capture and interpret whale sounds. This was no small feat, as the technology required to build such a studio did not exist. But the team's dedication and innovative thinking paid off. The recording studio was designed to operate deep in the ocean, where whales live and communicate. It could capture sounds in a way that no previous technology could. This was the first step in bridging the gap between humans and whales. The team's efforts were further supported by a generous grant from the TED Audacious Project, which provided $33 million in funding. With this support, the team was able to expand their research and take the next steps in their mission. They began collecting vast amounts of data from the sperm whales of Dominica, an island in the Caribbean that is home to a large population of these magnificent creatures. Dominica's unique geography, with its deep waters close to the shore, made it the ideal location for studying sperm whales. The island also provided a stable whale population, with many families returning year after year. With their advanced recording equipment in place and funding secured, Project SETI officially launched in 2020. The team began collecting an enormous amount of data, capturing millions of vocalizations from sperm whales. The next challenge was to make sense of all this data and begin interpreting the language of the whales. To do this, the team would need to use AI and machine learning technologies to analyze the recordings and find patterns within the sounds. The data they gathered was unlike anything previously collected. In the past, researchers might have gathered a few hours or even a few days' worth of whale sounds. Project SETI was capturing millions of vocalizations over many years. This massive dataset was crucial because AI models, especially machine learning algorithms, need large datasets to learn from. The more examples the AI had, the better it could understand the patterns within the whale sounds. This was the key to unlocking the language of the whales and understanding what they were truly saying. As the team continued their work, they began to realize that whale communication was much more complex than anyone had imagined. These animals weren't just making simple sounds. They were creating intricate vocalizations that were tied to social interactions and possibly even emotions. The implications of this discovery were enormous. If whales could communicate with each other in such a complex manner, what else could they be saying? What did their vocalizations reveal about their culture, their social structure, and their intelligence? And perhaps most importantly, could we learn to communicate with them? This was the challenge that Project SETI faced, to decode the language of the whales, and eventually to establish a two-way communication system. What they uncovered was far beyond anyone's expectations. What started as a simple quest to understand whale songs had turned into a groundbreaking scientific mission that could change the way humans interact with the creatures of the sea. As Project SETI progressed, Dr. Gruber and his team faced an increasingly complex challenge: how to go beyond simply listening to whale sounds and move toward truly understanding them. While the breakthroughs in technology had already opened new doors, the real challenge lay in decoding the intricate patterns within the vocalizations. To achieve this, the team needed more than just advanced recording equipment. They needed to build a comprehensive system that would allow them to translate the sounds into meaningful communication. This system would not only help them interpret the sounds but also eventually establish a two-way dialogue between humans and whales. One of the most innovative ideas behind Project Decoded was the concept of integrating artificial intelligence (AI) into the research process. While the team's goal was to understand whale communication, they also knew that AI could play a critical role in analyzing vast amounts of data. AI was capable of processing information far more efficiently than human researchers could on their own, and this was essential given the enormous volume of sounds they were collecting. The technology would allow the team to identify patterns and meanings that would be almost impossible for humans to detect using traditional methods. Dr. Gruber's vision for using AI came from his realization that decoding whale sounds was not a task that could be achieved with conventional tools. It was a monumental task that required the ability to process and understand the sounds at a level far beyond what was previously possible. In this regard, Dr. Gruber turned to the expertise of specialists from various fields, particularly those with experience in machine learning, natural language processing, and computer science. The team needed these experts to help design algorithms that could interpret the complex sounds made by the whales. The role of AI in Project Decoded was more than just listening to the sounds. It was about understanding who was speaking to whom and why. The challenge was to move from simply hearing the sounds to understanding the context in which they were made. This was crucial because whale communication, as the team quickly realized, was not just a series of random noises. Each click, whistle, or moan had a specific meaning, and the meaning often changed depending on the context. To decode this communication, the AI had to learn to recognize not only the sounds themselves but also the subtle nuances and variations in rhythm, tempo, and structure that defined each vocalization. This is where the expertise of linguists came into play. The team understood that whale communication might not be entirely different from human language in some ways. While the sounds made by whales were vastly different from the words humans speak, the underlying principles of communication were likely similar. Just as humans use language to convey complex thoughts and emotions, whales may have developed their own system of communication to share information, coordinate activities, and express feelings. The linguists on the team worked closely with the computer scientists to develop algorithms that could detect and interpret these patterns. One of the critical breakthroughs for the team came when they decided to build an underwater recording studio that would be specifically designed for capturing and analyzing whale sounds. This was a significant leap forward in the project, as it would allow them to collect data on a scale that had never been attempted before. In previous studies, researchers had used basic microphones and recording devices, but these tools had limitations when it came to capturing the full range of sounds produced by whales. By creating a dedicated underwater studio, the team was able to create an environment that could record whale vocalizations with incredible precision. The underwater studio was equipped with an array of hydrophones, or underwater microphones, which were placed strategically around the study area to capture sounds from multiple angles. These hydrophones were capable of picking up even the faintest clicks and whistles, which were essential for understanding the nuances of whale communication. The data collected by the hydrophones was then fed into the team's AI system, which began the process of analyzing the sounds. The AI was able to break down the sounds into their individual components and identify patterns that humans could not hear with the naked ear. In addition to the hydrophones, the team also used robotic systems to gather data on the whale's behavior. These robots were equipped with sensors that could track the movements of the whales and collect data on their social interactions. By using non-invasive methods, the team was able to gather information about the whales' behavior without disturbing them. The data collected by the robots, combined with the audio recordings from the hydrophones, gave the team a much clearer picture of whale communication. They were no longer just listening to the sounds, they were understanding the context in which the sounds were made. The AI system played a crucial role in making sense of this massive amount of data. Machine learning algorithms were trained to recognize patterns in the whale vocalizations, and over time they became better at distinguishing between different types of sounds and identifying the meanings behind them. The AI was able to detect subtle variations in rhythm, tempo, and pitch that were indicative of specific messages or emotions. For example, a certain pattern of clicks might indicate that a whale was communicating with a member of its pod, while a different pattern might suggest that the whale was warning others about a potential threat. As the AI system grew more sophisticated, it began to reveal the complexity. It wasn't just a series of random noises, as previously thought. Instead, it became clear that whales were using their vocalizations to convey a wide range of information. They communicated with each other about food, danger, social interactions, and even emotional states. The vocalizations were more akin to a language than a simple set of noises. One of the most exciting discoveries made by the team was the identification of specific codas, which are sequences of clicks that are used by sperm whales to communicate. These codas were found to be far more complex than anyone had previously imagined. The team discovered that each coda had its own meaning, and that the whales used them to convey a variety of messages. Some codas were used for communication within the pod, while others were used to signal danger or to mark a territory. What was particularly fascinating was that the codas varied from pod to pod, suggesting that each group of whales had its own dialect. This discovery was a turning point in the project. It showed that whale communication was not a universal language but was instead shaped by social factors and cultural influences. Just as humans speak different languages depending on where they live, whales also had regional variations in their vocalizations. These findings suggested that whale communication was much more sophisticated than anyone had realized. The team had uncovered a complex system of communication that was not unlike human language in some respects. The breakthrough in understanding the codas was a crucial step in the team's mission to establish a two-way communication system with whales. With a better understanding of how whales communicate, the team could begin to work on developing methods for responding to them. The goal was not just to decode their language but to be able to speak to them in return. The AI system, which had been trained to understand whale vocalizations, was now tasked with generating responses that would be meaningful to the whales. This was a bold and ambitious goal, but it was one that the team was determined to achieve. As the project progressed, the team began to make significant strides in developing a way to communicate with the whales. They used the data collected from the hydrophones and robotic systems to generate specific sequences of sounds that mimic the whales' codas. The idea was to play these sounds back to the whales using underwater speakers and see if they would respond. This marked the beginning of the next phase of Project C, moving from listening to the whales to talking to them. The process of creating meaningful communication with whales was no small feat. It required not only a deep understanding of their vocalizations but also the ability to create a system that would allow for real-time interaction. It was a monumental task that required collaboration between scientists, engineers, and computer experts. But with each new discovery, the team grew more confident that they were on the right track. They were no longer just recording whale sounds, they were starting to speak the language of the whales. The first challenge in this new phase was the collection of real-time data. Previously, the team had relied on recorded vocalizations from the whales, but now they needed to capture the sounds as they happened, in real time. The solution was to deploy a network of sensors, specifically hydrophones, across the ocean floor. These underwater microphones were able to record every sound in the surrounding area, from the faintest clicks to the loudest whale songs. The network was designed to operate 24/7, ensuring that no communication was missed. What made this new system so impressive was its scale. The hydrophones were deployed in a grid-like pattern that spanned a vast area of the ocean. This allowed the team to capture the sounds of multiple whales at once, even if they were far apart. The sensors didn't just pick up the sounds, they also tracked the exact location of each sound. By pinpointing the location of each click or whistle, the team could determine which whale was making the sound and in what context. This level of precision was crucial for understanding the meaning behind the sounds. It wasn't just about hearing the noise, it was about knowing who was speaking, who they were speaking to, and why. Once the sounds were captured, the data was sent to the AI system for analysis. The The AI was responsible for identifying the different patterns and variations within the sounds. It could detect subtle changes in rhythm, pitch, and tempo, allowing it to distinguish between different types of communication. For example, certain sounds were used in social interactions, while others were used in warnings or when hunting for food. By analyzing these variations, the AI was able to create a more accurate picture of the whale's communication system. The next step was to figure out how to respond to the whale. The team wanted to create a system where they could not only understand what the whales were saying but also communicate back. The solution came in the form of underwater speakers. These speakers were designed to emit the same sounds that the whales were using. The idea was simple: if the team could mimic the sounds that the whales were making, they might be able to engage them in a conversation. But the process was far more complicated than it sounds. The team didn't just want to mimic the sounds, they wanted to understand the meaning behind the sounds and respond appropriately. This meant that the AI system had to be capable of generating responses that were contextually relevant. For instance, if a whale made a particular sound to indicate that it was warning others of a predator, the team would need to respond in a way that acknowledged the threat. Similarly, if a whale made a sound related to social bonding, the team would need to generate a response that was consistent with the nature of the interaction. To achieve this, the team needed to create a library of whale sounds that could be used to generate meaningful responses. This library, which was built up over years of data collection, included thousands of vocalizations, each with its own specific meaning. The challenge was not just to understand these sounds but to use them in a way that made sense to the whale. The team had to ensure that their responses were not just random clicks or whistles but meaningful messages that could be interpreted by the whales in a way that made sense to them. The underwater speakers were tested in the waters off Dominica, an area where sperm whales were frequently found. The first tests were conducted with a single whale, and the results were remarkable. The team played a sequence of whale sounds through the speakers and waited for a response. To their amazement, the whale responded with the same sequence of sounds. It was a direct back-and-forth exchange, something that had never been achieved before. The team was ecstatic. For the first time, they had successfully initiated a conversation with a whale. This breakthrough was significant for several reasons. First, it demonstrated that the AI system was capable of understanding whale communication on a deeper level. The AI had been able to identify the whale's vocalizations and generate an appropriate response. Second, it proved that the whales were capable of engaging in meaningful interactions with humans, at least to some degree. The whale had responded to the AI-generated sounds in a way that suggested it understood the purpose of the interaction. The success of these early tests led the team to take the next step, expanding the communication system to include multiple whales. The hydrophone network, which had been instrumental in tracking individual whale vocalizations, was now used to capture the sounds of entire pods of whales. The AI system was updated to handle the increased volume of data and to track the vocalizations of multiple whales simultaneously. This allowed the team to understand not just individual communication, but the social dynamics of the whale pods. With the new system in place, the team was able to conduct more complex experiments. They played sequences of sounds to entire pods of whales and waited for responses. In some cases, the whales responded immediately, while in others, they appeared to deliberate before replying. The team observed that the whales often used specific vocalizations in particular social contexts. For example, a whale might use one set of sounds when communicating with a close family member and a different set when communicating with a member of another pod. This revealed a level of social sophistication that had never been seen before in non-human animals. The implications of these findings were far-reaching. For one, it confirmed that whale communication was much more complex than previously thought. It also suggested that whales, like humans, might have a rich social life, with intricate relationships and cultural norms. The team had not only decoded the language of the whales, but also discovered a new way of understanding their social structure and behavior. As the project continued to expand, the team began to look at the ethical implications of their work. The ability to communicate with whales raised important questions about the role humans should play in these interactions. Some scientists worried that engaging in two-way communication with whales could have unintended consequences. Would the whales be able to understand the impact of human interference? Could their natural behaviors be disrupted by our attempts to communicate with them? These were questions that the team took very seriously, and they worked hard to ensure that their interactions with the whales were respectful and non-intrusive. Despite these concerns, the team was optimistic about the future of whale-human communication. They had already made significant progress in understanding the whale's language, and they were confident that their work would have profound implications for both marine biology and our understanding of animal cognition. The ability to communicate with another species, even one as different from us as whales, was a monumental step forward in the field of animal communication. It not only challenged our assumptions about the intelligence of non-human animals, but also opened up new possibilities for the future of interspecies dialogue. In 2023, the team achieved another milestone: the first intentional human-whale interaction using the language they had decoded. Using a specially designed underwater speaker, a diver played a sperm whale coda to a group of whales. To everyone's astonishment, one of the whales responded with the exact same coda. This was not just a random occurrence, it was a direct exchange between humans and whales. The implications of this success were profound. It proved that the team had succeeded in creating a system of communication that could be used for meaningful interactions between humans and whales. Looking to the future, the team is already planning to expand their research to include other species of whales, such as orcas, and refine their AI algorithms to improve the accuracy of their translations. The work of Project Seed has already transformed our understanding of whale communication, but the team is far from finished. As they continue to refine their methods and develop new technologies, the possibilities for understanding and communication with whales and other species are limitless. What began as an ambitious dream has now become a reality, and the implications of this work go far beyond the ocean. The ability to communicate with another intelligent species is a breakthrough that could change the course of science and our relationship with the natural world.